In this example, we have to find the Fourier transform of this function fx. Now it is defined from 0 to a as 3x power 4 and it's 0 otherwise. Now we know that Fourier transform of any function, we write it as 1 over square root of 2 pi. Generally we express it in terms of t, but here it's okay. If you want to change the formula as per your question, as your function is in x, you can modify the formula as f of x e power minus iota sx dx. Means you can convert the variable t in terms of x. Okay, in the previous example we have seen that we are converting here x in terms of t. So that is one option. Another option is you just convert here variable x in terms of t. Okay, so both ways are correct. So let me explain how it will work when you are using this formula. So when you are using this, we replace the value of fx by this in this interval 0 to a. So we get fs as 1 over square root of 2 pi integral, limit is from 0 to a. Now here again a is a constant, 3x power 4 e power minus iota sx dx. Again under the integration two terms are in multiplication and it's not possible to combine them together to make it one term. So we have to integrate it by parts. So again, as one of the function is algebraic, we can use this concept. We select this function for derivative and another function for integration. So it is 3x power 4 e power minus iota sx. Note that you can use this formula only when one of the function is such that after certain derivatives it becomes 0. If you don't have that function, you cannot go for this method. Then you have to go for normal UDV method of integration by parts. So derivative is 12x power 3. Then 36x power 2. Then how much it is? Here it is 6 2 so 12, 72x. Derivative 72 and its derivative 0. See, you have to differentiate 5 times to make it 0. Integrate it same number of times. E power minus iota sx over minus iota s. Here e power minus iota sx over minus iota s power 2. E power minus iota sx third time, the power become 3. Fourth time, the power become 4. And fifth time, the power become 5. And then assign the signs to get the term. So we start with positive. As we move to the next step, change the sign. Positive, negative, positive, negative. And multiply in cross. 1, 2, 3, 4 and 5. So there are 5 terms in this expansion. So just write it down. 1 over square root of 2 pi integral plus plus is plus 3x power 4 e power minus iota sx over minus iota s. Then minus 12x power 3 e power minus iota sx over minus iota s to the power 2 plus 36 x square e power minus iota sx minus iota s to the power 3. Then minus 72x e power minus iota sx over minus iota s to the power 4. And then plus 72 e power minus iota sx over minus iota s to the power 5. X varies from 0 to a. Now next step is just to replace the value of x by a. Then you can easily do. So you have to, don't forget that you have to replace x at all the highlighted places. Okay, first replace x by a and then minus by 0. So when you replace it by 0, you left with only this non-zero term, because all other terms have x is equal to x there in multiplication. So in this way you can complete it. Okay, let me just write it. It will come as 1 over square root of 2 pi 3 a power 4 e power minus iota s a over minus iota s minus 12 a power 3 e to the power minus iota s a over minus iota s to the power 2 plus 36 a square e power minus iota s a over minus iota s to the power 3. 72a e power minus iota s a over minus iota s to the power 4, and here 72 e power minus iota s a over minus iota s to the power 5. And when you substitute the limit 0, first, second, third, fourth, all 4 terms have x, so it becomes 0. And here e power 0, which is 1. So you left with 72 over minus iota s to the power 5. So this is the Fourier transform of the function. You can further simplify it by using the property of I. We know that iota square is minus 1. Iota cube will be minus iota. Iota to the power 4 will be plus 1, and so on. So you can work with it. So similarly, if we have to find the Fourier transform of the function fx, which is takes value 1 when x lies between from minus 1 to 1 and it's 0 otherwise, so this condition can also be expressed as mod x less than 1. Okay, so again, by using the same concept, what we will do, first we write down the formula, and as the value from minus 1 to 1 is 1, we will write here 1. Okay, so here when we integrate, we divide it only by minus iota s, because that is the coefficient of it. Minus iota s is the coefficient of x, so we divided by it, and then we replaced x by 1 and then by minus 1 to get this as the final answer. Okay. Similarly, now if I divide the function into 3 parts, say it takes value 4x when x is from 0 to 1, and it takes value 4 minus x when x varies from 1 to 4, and it is 0 otherwise, then in this case the Fourier transform will have 3 different parts. So let's see how it will be, because see, we have 3 different integrals. Okay, third part will be 0, so we have only 2 non-zero part. So what it will be? It will be, say, fs is equal to 1 over square root of 2 pi. Here let's assume that we are changing the variable x in place of t. So it is now from 0 to 1. So we write integral 0 to 1. The value of function is 4x. Integral is minus iota ix dx plus, now integral 1 to 4. Value is 4 minus x e to the power minus iota x dx. See what we did, we have used this formula of Fourier transform, which is 1 over square root of 2 pi minus infinity to infinity f of x e power minus iota x dx. Now here your function f of x, here the function f of x is defined from minus infinity to infinity. So this entire interval of minus infinity to infinity we divide it as per our values. We have value from 0 to 1 and then we have 1 to 4. So in this interval the function takes value 4x, and in this interval the value is 4 minus x. In the remaining interval the value is 0. So we write from 0 to 1 the value as 4x. From 1 to 4 the value is 4 minus x. In remaining intervals the value is 0, so we don't write it. Then we integrate these two parts separately to get the final answer. And you can easily see that both are the integrals which have to be answered by parts. So this will be the final answer, the Fourier transform of this function. So these are the steps you have to follow. Here you can see that here it is minus iota s square, and when I wrote here it's only s square. So how do we work on it? If it is minus iota s square, it means minus iota square s square. So minus 2 times become plus iota square s square, and since iota is a complex number, so it becomes minus s square. So minus iota s square become minus s square, and this minus become plus. So since iota square is minus 1, we are using this property to simplify to these terms. Okay. So other things are like if I change the function, like it takes value x from 0 to 1 and 1 minus x from 1 to 2. So this is how we work with the integral of it.